Hi everyone, we'll be presenting part 4 of Grammar as Science. Let's start with an important point. For example, let's take this famous sentence by Chomsky. Colorless green ideas sleep furiously. It sounds strange and meaningless. Still, it follows proper English order. Adjective plus noun plus verb and adverb. So it's well formed, even though it's nonsense. Now compare it with this sentence. Colorless sheep furiously, ideas green. This one does not follow English grammar rules. The word order is all wrong. That means it is not well formed. So the key idea here is being well formed is about grammar and structure, not meaning or naturalness. Next, let's talk about how being well-formed is not the same as being grammatically proper or educated. We often learn in school that some sentences are wrong, like ending a sentence with a preposition or using me instead of I. For example, who are you going with might be called improper in grammar class, but many native speakers use it all the time, and everyone understands it. Linguistics don't focus on whether a sentence is correct by school standards. Instead, we care about what people actually say and understand. So again, well-formedness is about what's natural and acceptable to native speakers, not about what sounds formal or academic.
Some sentences sound strange to native speakers. This can happen for two reasons. First, a sentence may be unacceptable. That means the speaker doesn't like it, maybe because it sounds weird or meaning is unclear. Second, a sentence may be ungrammatical. This means the sentence breaks the grammar rules that the speaker knows in their mind. So, all ungrammatical sentences are unacceptable, but not all unacceptable sentences are ungrammatical. In the textbook, we see examples. Sentences like Bertrand or Maggie Cross are well formed. They follow grammar rules. But when Maggie or Cross Homer are ill formed, they do not follow grammar rules. We can make grammar rules to explain why some sentences are correct. For example, S goes to NV can make Bertrand. S goes to NVN can make Bert so Maggie. If a sentence fits these rules, it is well formed. If it doesn't, it is ill formed. In conclusion, both good and bad sentences are important in linguistics. They help us understand the grammar that speakers really use in their minds.
And from now on, I'd like to talk about how we formulate a grammar, how we build a system of rules that can describe the structure of a language. To start, grammars are usually made up of two basic types of rules. These are called lexical rules and structure rules. Lexical rules are used to classify individual words into specific grammatical categories. For example, noun and verb. So lexical rules tells us what kind of word each one is. This helps us build up a stock of words that our grammar can work with. And structure rules tells us how those categories can be combined to form sentences. They define the possible arrangements of grammatical categories in a language. So, while lexical rules helps us list the words in our grammar, structure rules tells us how to put them together. This means that whenever we are trying to build or revise a grammar, we need to think about both types of rules. And if we are adding both new words and new patterns, we'll have to add both kinds of rules. Now let's talk about how to actually build a grammar in a smart and organized way. Sometimes we might look at lots of example sentences and try to write down all the rules at once, but that can get confusing really fast, and we might end up with rules that don't actually work well together. So instead, the book suggests a more careful method, kind of like following a recipe step by step. Here's how it works. First, we start with the just one sentence, a sentence we know is grammatical. Then we create just enough rules to explain only the sentence. Next, we take a second sentence and try to expand our grammar to include it as well. But as we do that, we always check, do the new grammar rules still work for the first sentence? If yes, it is great, and we move on. But if not, we go back and fix the problem. And then we repeat the process with each new sentence, adding rules by one, always making sure the grammar still explains everything we've done before. It's a very careful and step-by-step way of building a grammar. Then why is this method so useful? Because it helps us avoid two major problems. One, we don't want to make a grammar that accidentally allows ungrammatical sentences. Two, we don't want to lose the good sentences we already had. So every time we add something new, we double-check that we haven't broken anything. It's kind of like building a tower. You add one block at a time and make sure the structure stays strong and stable. In the end, this method helps us build a grammar that's not only correct but also clean, consistent, and easy to manage.
In this example, we can see how building a grammar is similar to developing a scientific theory. We don't just list random rules. We build a system step by step, testing and improving it as we go. We begin with a simple sentence, Bart ran. To generate this, we set a basic rule. A sentence consists of a noun followed by a verb, followed by a verb. We define Bart as a noun and ran as a verb. This gives our first successful result. But of course, we don't stop there. We want our grammar to handle more sentences, like Homer sleeps or Maggie crawls. For that, we add new nouns and new verbs to the system. After updating the grammar, we go back to check if our original sentence, Bart ran, is still generated. That's how we make sure that expanding the system doesn't break what we've already built. Creating good sentences isn't enough. A good grammar also prevents bad sentences. Take ran Maggie for example. It's ungrammatical. And when we test our grammar, we find that this sentence isn't generated. That's exactly what we want. Finally, we increase the complexity by adding a sentence like Homer chased Bart. This requires another rule, allowing a sentence to have a noun, a verb, and another noun. Once again, we test everything, old sentences, new sentences, and possible mistakes to make sure the system is working properly. What this process shows is that grammar isn't just about memorizing rules. It's about building a model, testing predictions, correcting mistakes, and constantly improving the system, just like the scientific method. Thank you.